Hi, our topic for this video is solving rational inequalities. Note that there are 4 steps in solving rational inequalities. Our first example is x plus 2 over x plus 3 is lesser or equal to 2. First step in solving rational inequality is to rewrite as a single rational expression on one side of the inequality symbol and 0 on the other side. In our example, x plus 2 over x plus 3 transpose 2 to the left side, this will become negative 2 is lesser or equal to, the right side will now be 0. Next, let us make x plus 2 over x plus 3 minus 2 as a single rational expression by getting their least common denominator. Since 2 is a whole number, we can put 1 as its denominator. The LCD of x plus 3 and 1 is x plus 3. Since the denominator of the first term is retained, then let us just also copy the numerator x plus 2. Minus x plus 3 divided by 1 times 2 is 2 times x plus 3 is lesser or equal to 0. X plus 2, negative 2 times x is negative 2x. Negative 2 times 3 is negative 6. Copy denominator, x plus 3 is lesser or equal to 0. Combine like terms, x minus 2x is negative x. 2 minus 6 is negative 4 over x plus 3 is lesser or equal to 0. To make x positive, let us multiply this with negative 1. Negative 1 times x will now be positive as well as 4. Copy denominator, x plus 3 is lesser or equal to 0. Next step is to find the value or values that will make the numerator 0. Our numerator is x plus 4 equate to 0. We will not include negative 1 because if the expression x plus 4 will be 0, regardless of what number is being multiplied, that is still equal to 0. X plus 4 equals 0, transpose 4, it will be changed to negative 4. X equals negative 4. Next, find the value that will make the inequality undefined. By equating the denominator to 0. X plus 3 equals 0. X equals negative 3. Let us plot the points in a number line. If this is 0, 1, 2, 3, this is negative 3 and negative 4. If the inequality uses lesser than or greater than symbol, all our points in the number line will use hollow circle. However, if the inequality uses lesser than or equal to or greater than or equal to, we will use hollow circle for the values that will make the denominator 0 or undefined, but shaded circle for the values that will make the numerator 0. Since the inequality symbol used in our example is lesser than or equal to, we will use hollow circle for -3 and shaded for -4. Observe how many intervals are present in the number line with regards to the points. We have 1, 2, and 3. 3 intervals present. Next step is to construct a table of signs. First, let us identify the intervals. First is this area. The values here are lesser than -4. So the first interval is x is lesser than -4. Since -4 uses shaded circle, we will also use or equal to in the inequality symbol. Next is this area between -4 and -3. So our interval is -4 is lesser than or equal to x, and x is lesser than -3. Next interval is this area. The values in this area are greater than -3. Next row, identify test points. For our first interval, x is less or equal to -4, we will use -5. For the second interval between -4 and -3, we will use -3.5. And this area x is greater than -3, let us use x equals 0. Then, write all the factors of the numerator and denominator from step A. We have -1 times x plus 4 and x plus 3. And in the bottom, write the entire rational expression. -1 times x plus 4 over x plus 3. In this column, x is equal to -5. -5 plus 4 is -1. -1 times -1 is +1. So we will write positive. -5 plus 3 is -2. Positive divided by negative is negative. -3.5 plus 4 is positive 0.5. 0.5 times -1 is -0.5. -3.5 plus 3 is -0.5. Negative divided by negative is positive. 0 plus 4 is +4 times -1, -4. 0 plus 3 is +3. Negative divided by positive is negative. Since this inequality uses lesser than or equal to 0 symbol, it implies that we are looking for the negative values. For our final answer, trace the intervals that produce negative answers. First is x is lesser or equal to negative 4. Or, which stands for union, x is greater than negative 3. This is the final answer in set notation. If we express this to interval notation, this will be x is lesser than or equal to negative 4, negative infinity until negative 4, union negative 3 until positive infinity. Notice that we use bracket in negative 4 because its inequality symbol uses or equal to. Second example, 2 over x is greater than 1 over x minus 3. First step, let us transpose 1 over x minus 3 to the left side. This will be 2 over x minus 1 over x minus 3 is greater than 0. Next, to make this as a single rational expression, let us identify their least common denominator. To get their LCD, just simply multiply both denominators. X times x minus 3. X times x minus 3 divided by x, cancel x, only x minus 3 is left. So times 2, this will be 2 times x minus 3 minus x times x minus 3 divided by x minus 3, cancelled x minus 3, only x is left. X times 1 is x is greater than 0. Next, 2 times x is 2x. 2 times negative 3 is negative 6 minus x over x times x minus 3 is greater than 0. Combine like terms, 2x minus x is x, copy negative 6, then copy denominator, x times x minus 3 is greater than 0. Next step, the value that will make the numerator 0 is x minus 6 equals 0. This is x equals 6. On the other hand, the values that will make the denominator 0 are x equals 0 and x equals 3. X equals 0 comes from this factor, equate to 0, therefore x is equal to 0. And x minus 3 is from the other factor, x minus 3 equals 0, that is x is equal to 3. Plot the points in the number line. If this is 0, 1, 2, 3, 4, 5, 6. The symbol used in this inequality is greater than. Therefore, we should use all hollow circles for all our points. So 0, same with 3, as well as 6. Based on the number line, there are 1, 2, 3, and 4 intervals. Next, let us construct the table of signs. First interval is this area, and the values here are lesser than 0. So x is lesser than 0. Second interval is between 0 and 3. 0 is lesser than x and lesser than 3. Third interval between 3 and 6. This will be 3 is lesser than x and x is lesser than 6. And fourth and last interval, the values here are greater than 6. So x is greater than 6. Next, identify test points. Lesser than 0, I will use -1. Between 0 and 3, 1. Between 3 and 6, we will use 4. And greater than 6, let us use 7. Next, write all the factors of the numerator and denominator. We have x minus 6, x, and x minus 3. And at the bottom, write the entire rational expression. X minus 6 over x times x minus 3. -1 minus 6 is -7. -1 is negative. -1 minus 3 is -4. Since x and x minus 3 are factors of the denominator, let us multiply them first before dividing it from x minus 6. Negative times negative is positive. Negative divided by positive is negative. 1 minus 6 is -5. 1 is positive. 1 minus 3 is -2. Positive times negative is negative. Negative divided by negative is positive. 4 minus 6 is -2. 4 is positive. 4 minus 3 is positive. Positive times positive is positive. Negative divided by positive is negative. 7 minus 6 is +1. 7 is positive. 7 minus 3 is +4. Positive times positive is positive. Positive divided by positive is also positive. For our last step, since our rational inequality symbol is greater than 0, therefore, we are looking for positive values. We have the second interval and the fourth one. For our final answer, we will write this interval. 0 is lesser than x and x is lesser than 3, or this interval, x is greater than 6. In interval notation, this will be 0 until 3, union 6 until positive infinity. That is all for this video. I hope that you learned how to solve rational inequalities. Please like and subscribe for more math tutorials.